Okay, hello everyone. Welcome to this month's WasmEdge Community Meeting. And today we have two sessions. The first session is I will talk about the Google Summer of Time, the project idea that's proposed by WasmEdge Community. And the second session will be the how I use Cloud Code to upgrade the WasmEdge Rust SDK and spoke by Michael. So let me share my screen and for the Google Summer of Code part. Can you guys see my screen now? Okay, so let's get it started. And if you check the CNCF project ideas for the Google Summer of Time, and you will see that we propose three project ideas here. And I would like to say that due to the limitation of the quarter, I believe um, even we have lots of proposals around these three project ideas, but in our previous sessions, most of the time, only one proposal will be picked or zero. It happened before. And because this decision is made by the Google committee, and we don't have the decision of it, the only thing we can do is to according your proposals to sort the priority. For example, which person is the first priority that we want to pick, and then we will send these informations to the Google Summer of Code community, and they will make the decision. So we have no idea how the decision is made, but the only thing we can do is to to say that in each of the project idea, what is the most important criteria to apply for these corresponding proposals. So let's start with the first one. So the first project idea is to refine the Wasm instruction structure in WasmEdge project. So you can ignore this time because that's in our very beginning, we only have a single project ideas. However, after some discussions, we add two more. So it's fine to ask question now. Yeah, so this is just the previous state. I will update that after the meeting. And let me scroll up. Let me read the page. So basically, we have already defined some Wasm instructions, and according the current design, we believe that is some instruction classes have to refactor for us to do some analysis and do some optimizations in our code base. So in this whole idea is that you need to get familiar with the fundamental data structure used by WasmEdge, and then help us to separate the optical vectors and immediate data. And because in the previous designs, we bundle them together, and that causes us, if we want to do some aggressive optimization, it will be a blocker. So that's why we want to refactor the whole data structure to make this happen. So once you do the refactoring, then you have also need to update the corresponding tests to ensure that all of the behavior is correct. And please notice that in the current design, we should have 80% of the coverage of this code. So if you're going to apply this one, you have to ensure that after your refactoring, after your updating, after your modification, the coverage still keep the 80% or upper. And of course, because this is refactoring to the fundamental data structure, so you have also need to perf the memory usage to prove that your implementation is to enhance the whole runtime, not downgrade the performance of this runtime. So that's the intention of this whole project idea. And we believe you must have the basic idea about the C++ and of course the WebAssembly. And the pretest is still preparing, and all of these three are still preparing, and we will release it this Friday. So yeah, just wait a couple days and we will update the pretest. Then okay, so this is for the first one. And the second one here is we want to implement the ahead of time and just-in-time compilation for the exception handling proposals. So what's the background? The background is that the exception handling proposal is already merged in the Wasm 3.0, and we already support yet in the interpreter mode. However, the ahead of time and the just-in-time compilation is not yet supported. So we expect that the Mentee need to implement this proposal. And of course, the spec test must be passed. And the reason we put the ahead of time compilation here and the JIT together because that the current JIT implementation is just a one pass JIT compilation, which means that you get a module and the whole module will be compiled before its execution. So the behavior will a little bit similar like the ahead of time compilation. But the ahead of time compilation is that you will run compilation first, and you will get the compiled Wasm file and then execute it. And JIT just group these two steps into one. Yeah. So that's why we put them together. I believe if you have the background of the LLVM, and it should be fine to understand how to implement this whole project idea. Yep. So this is the second one. And the same, the pretest will be updated this Friday. So let's move to the third one, is that this is from our previous community meeting, which is hosted in the January this year. And the Kotlin team says they are evaluate that they want to add the branch hitting to the Wasm target. So they would like to know if we are going to support this proposal. So I believe branch hitting will help us to to improve the performance, and we can get more information to do some analysis. So we decide to have this project idea here, and it actually is a two phases project, because that's the branch hinting proposal will rely on the customization policy. And in our current design, we only pass some customization that is meaningful to the Wasm runtime. For example, we have the universal universal Wasm file, which is a file format that we put the compiled Wasm into the custom session. So you will get a Wasm file, which is the original pure Wasm, and plus a custom session, which is stored the compiled instructions inside that. And the ahead of time runtime will read that part of the as the the execution code to do the whole execution. Yeah. So in this project idea, you will need to add a series of test case that's verify the behavior of the custom session parsing. And I believe is you don't need to implement it in a very detailed way, because the original idea is that we need to store the branch hitting data in the custom session. So the whole design is that you only need to fulfill the minimum requirement that the branch hitting proposals can be write and can be read from the custom session. So that's the reason I would say is the two phases, because you have to implement the custom session parsing first, and then to do the branch hitting proposals. And of course, the implementation is required, and you have to pass the spec test from this proposal. And of course, you have to write a document that to talk about how to use it. Okay, and this is to our three project ideas. And sorry, I missed to add this section in these two ideas. Before you apply, please make sure that you read and understood the mentorship program policy. So I will repeat most of the important part here. And this is for the application phases. We are not allowed any private contact. The reason is that to be fairness, we don't want to answer some of the people, but some of the other people cannot get the communication. So if you want to discuss any ideas about these three project ideas, you can leave your comments on that, and we will answer it. All of the private contacts are not allowed. So you cannot use email, use Slack, use Discord to contact us directly. Yeah. And the second one is that we are not accept any AI spam, including if you are trying to send any issues or pull requests, they are AI generated, and you have no idea, or you are not reviewed what the AIs did, and yeah, we will just ignore your applications. And of course, you cannot copy others' work as yours to put into the proposals. And if you have other questions, for example, any details to the whole mentorship program or the Google Summer of program, and the only thing we can answer is all about our project ideas. So if you have any questions related to the organization or related to the payment or any other questions, you have to contact, for example, contact to CNCF or contact to the Google Summer of Tour organizations. Okay, so that's the basic managerial policy you must follow. And yeah, that's all of the section. And I will hand over to Michael for his session. Thank you.
All right. Thank you, Haidai. So I guess there are some questions. Maybe you can answer the questions first.
Okay, so I get a question is, can we get a review of our draft proposals from any mentors and where to send it? The answer is no, we won't review any proposals before the deadline. The reason is that um, we won't do any private reviews. If you want to do that, the only way you can do is to post your idea on the issue board, and we will answer it publicly. Yeah. So that's it for your first questions. And the second question, either zero or only one of these three proposals are going to be accepted. Uh, yes, because I believe, sorry, I don't remember which year, but one year that we have several proposals we submitted, and I'm not sure the what's the situation that year, but uh we don't have any of yet accepted by the Google Summer of Code committee. So we don't know the answer, but there's one year that zero proposal is accepted, and most of the cases, I believe, only one of yet will be accepted. Most of the cases, yeah, and it's very rare that we will be accepted more than one. Yeah, that's uh that's from the previous experience, and I have no idea how it's going to work. Yeah, so that's for your second questions. Uh, is the selection criteria completed based on the quality of a proposal, or do we need to initial contribution to WasmEdge? Basically, you should put all your application materials in the proposals, include anything that you believe that can enhance your chance. Okay, so we only review any materials you put in your proposals. And do you need to do any contribution to WasmEdge? And that's not must be criteria in our selection. Yeah. So basically, we will all based on what you submitted to us to make a decision. Okay. I think there's no more question. Maybe Michael, you can go ahead.
Okay. All right. Yeah. So thank you, Haidai. So yeah, I think one of the things I would add is that a lot of our Google Summer of Code proposals you know that wasn't accepted by Google Summer Code end up to become LFX mentorship programs. So there's multiple intern opportunities. All of them are paid throughout the year, and the LFX internship mentorship is a much bigger, or at least to us, it's much bigger program. We have like 10 or more students every year. Google Summer of Code is a bigger program overall, but for us, like Haidai said, it's they are selecting 0 to 1 project from us, like uh, every time, right? So it's smaller for us. It's smaller than the FX mentorship program. And the other thing that that I might add is that uh, from what I heard from the Google Summer of Code mentors, they are very against AI generated submissions, especially at the proposal page. The reason primarily is because they all look the same. That people find it's very boring. So I think to increase your chance there is to I would encourage people actually to use AI. However, be very careful about the human communication you generate from AI. So I think it's perfect fine to generate, as I'm going to talk about in a minute, is to use AI to generate code. I would encourage everyone to do that. However, when you write to people, be very careful. That's do not copy and paste from AI because I've seen a lot. That's it said AI said you can send this to Dr. Yuan, and something like that, and then just copy and paste the whole thing. Or the thing reads very much like what AI would do. At least read it once, and make changes because it makes mistakes. Okay, so yeah, that'll be the only thing that I would think of to increase your chances because if you go on those mailing lists, those mentors are rating against the AI generated submissions. You know, it's because a lot of this stuff is just very low quality, and people submit like 20 projects at once and all use AI to generate, right? So it's but anyway, so let me share my screen. Which one? Hold on. Yeah, this one. Okay. All right. I believe my screen is up here. So, since we're on the topic of AI, and that's the thing I primarily want to talk about, um, um, I want to talk a little bit about how we use AI and how, in both directions, how AI helped development of WasmEdge recently, and that's perhaps also one of the things that's happened to a lot of open source projects. And we would like to encourage our community to use AI extensively, but to use it correctly, right? And on the other hand, is how we think WasmEdge gonna benefit AI applications, right? That's so those are two separate things, but very connected. So on the screen, you see one of our early attempts to enable AI in the Wasm ecosystem. So it's a project called Llama Edge, right? So you can think of it as um, a much lighter weight of Llama. So when you install Llama, you have to have all those command line utilities and things like that. And then although only does large language model, it doesn't do you know like ASR or TTS, that sort of models. WasmEdge is a project that we wrote that's behaves much like Olama. It has a command line tool, except it's written in Rust and compiled to Wasm, so it's cross-platform, and it's also cross models. It's cross hardware as well, so it's utilize GPUs, NPUs, and all that, and runs a large variety of models, not just large language model, right? So and this project is based on a neural network extension of Wasm, called WasmN. So it allows us the the primary purpose of Wasm Place here is that it's a cross-platform runtime because in the age of AI, we thought there are many different hardware devices and all that different operating systems and especially many different hardware GPUs, NPUs, and things like that. So in order to embed your Wasm application into your other application, you need a cross-platform runtime so that you don't have to compile for each platform when you deploy. You can just have a single binary with a model and then, with the AI model and then just port it everywhere else. It's like the old days of Java, right? So, so we developed this project. This project, I think it's fairly well received. So that's one of our early attempts to help support AI in the Wasm ecosystem. Um, However, as you probably have also known, the landscape of AI has expanded dramatically, especially in the past 2 3 months. I would say 3 months since December 2025, right? You know, the capability of AI in coding and in doing agent work has exploded. So we are no longer satisfied with this simple ideas like this, just running AI inference in the Wasm ecosystem, right? So one of the things that has emerged as one of as a biggest need in the AI agent area is sandbox. as you can see, if you go on GitHub, there's a ton of new sandbox projects out there. So there's old sandbox project like, Docker is somewhat a sandcode project, and all the projects in CNCF, they all depend on containers, so sort of sandbox, right? And then you have things like, uh, micro VMs, right? So there's a lot of those. In fact, many of those written in Rust. And then you have orchestration frameworks. For instance, in fact, even Docker itself has a micro VM now. It's called a Docker Sandbox. It's just the name is just Docker Sandbox, right? It's an experimental feature. You can search it or check it out. And one of those, so there are also many popular sandbox orchestration frameworks, like I think E2B, and just a lot of those. And when CloudBot, or now it's called OpenCloud, come out, and one of the big criticism people have is that it's not sandboxed properly. So, people have to buy a Mac Mini to run it so that it can be isolated in its own environment, right? And when it's cross tools, it's also not using sandbox to isolate the tools and try to guarantee safety. So initially there are lots of security issues that are associated with OpenCloud. And if you see the OpenCloud updates in the past, I think past week or so, it's a lot of those are related to security. And how do they deal with security? They add sandbox to it, right? Either around the whole agent you are running, or have sandbox for each of the tools that you are running. So with this whole explosion of AI agent, I think sandbox become more and more important. And this, in my opinion, is one of the great opportunity for Wasm, because Wasm is a naturally sandbox environment. So um, actually, let me show you this project. So I don't know if you guys have seen the Ironclaw project. It's come from Near, it's one of the blockchain project, but the founder is one of the, seven original authors of the paper. All you need is attention, right? So this project, you can see it's already 4,000 stars. It's a Rust rewrite of OpenClaw, but the huge difference is that everything is sandboxed using Wasm, meaning that's so all the channels, for instance, how the bot communicates with, say, Telegram versus Slack, each of those connectors is sandboxed in the Wasm module so that outside developers can contribute more channels without breaking the overall security promise of the system. And on the other end, all the tools, so for instance, web search or Bash or other things, they each have their own Wasm sandbox as well, so that when people write new tools, it would not break the whole system's sandbox policy as well. So I think this is one of the well-received projects that makes extensive use of Wasm to help provide security guarantees of the whole system. And it is essentially a replicate of OpenCloud, but I just think it's OpenCloud done right. However, one of the regrettable things is that at least to us, right, so they choose Wasmtime instead of WasmEdge to run their sandbox. Although we are currently in the process of coming up with a WasmEdge version of this project, right? The reason is because I think WasmEdge provides a lot more interesting features than the Wasm runtime. However, there's one big advantage of Wasmtime, which I come to realize plays a very important role in using Wasm as a sandbox, especially Rust project, is that it's easy to use as a Rust SDK. So you just add a crate into your Rust project, and Wasmtime would be embedded into your application. So in order to reach that level of integration with Rust, it comes to me that we have to improve our WasmEdge Rust SDK. So I go back to our WasmEdge Rust SDK. You can see that's before the commits that I made this year. The last commit was made in December 2024. That's more than a year ago, right? So Why is it not being actively maintained? Because we have many projects in the WasmEdge ecosystem. I think there's only limited resources in terms of manpower and the community interest, right? Prior to the embedded use case of Wasm become popular again because of the AI agent, you know, most people using WasmEdge in the context like Llama Edge, which is a very frequently, uh, uh, updated project. And also WasmEdge itself, you can see, if you see WasmEdge itself, it's updated, only a couple weeks ago, so the version is already 0.16. And prior to, um, uh, you know, prior to early this year, the WasmEdge WasmEdge Rust SDK is frozen at 0.14, right? So it's two major versions behind the WasmEdge, the version of WasmEdge itself. So the reason is what I described because there are not a lot of use case for that. So people are less interested in contributing to it. So that causes the WasmEdge Rust SDK to be lagging behind, right? So the first thing that I thought, to bring Wasm to the as a first class sandbox in the age of AI agents, the thing that we need to really improve is to improve um, the WasmEdge SDK in different languages, so that when people write their AI application, it's easier for them to start a Wasm sandbox as opposed to, say, a container sandbox or the micro VM sandbox, right? So so we started updating the WasmEdge, uh, the started with the Rust version of the WasmEdge SDK and try to bring it up to date. And but like I said, we don't have manpower. So how do we do that? Because it's a substantial project. If I ask any of the developers to say how long does it take for for this to happen, the answer varies from a couple of weeks, something like that. Because there are lots of things to update. So what I did is I asked the AI to do it, right? So the AI come up with very large PRs like this, so those are the summary of what it did. Okay. And here are the files it changes. It's come up with the test first and then updated everything from, the test to build scripts and all that stuff. So, and then so it actually, in fact, over the course of a couple of days, it actually come up with two PRs. One is to upgrade the SDK from the older version of WasmEdge to the latest version of WasmEdge. And the second is, because one of the other features I want is that I don't want the user to install WasmEdge manually. I want when they use the SDK in their Rust application, for instance, when you're building it, it should either statically link WasmEdge or download WasmEdge binary by itself and put it side by side with the application binary, so that we can generate those self-contained binary distributions, right? So that we can send to users, and the user would be able to, without having to install system-wide WasmEdge, they would be able to just use the library itself, right? So I want to do the build time integration, and ideally on Linux platforms, I want to do static linking. That is not possible on the Mac. So I want to add this feature to the WasmEdge runtime. Again, it goes on. A lot of those are just made a comment and then it's did test, find it didn't work, and then come back and redo it, right? So it also, as you can see, most of the changes made here are not in the source code, but in the build system. So it can now build, in your Rust application when you pull in the WasmEdge runtime or when you pull in the WasmEdge sandbox through the WasmEdge SDK, it now has the option to automatically download the correct version of the WasmEdge library or static link it. Right? So there's um, so with those two improvements and and in fact, I didn't you know I didn't write a single line of code myself. I just reviewed the test cases and make sure they pass. And so we were able to bring the WasmEdge Rust SDK up to date. Those changes are thousands of lines of code change, right? So right after that, I thought we should go on and write an AI application ourselves using WasmEdge and Sandbox, and test out this SDK. So here's the AI application that I wrote. We're gonna probably announce it soon. So there will be the Wasm IO conference in Barcelona, I think, next month, and I'll probably go there and talk about this. So basically, one of the other things we have done in the past is we have done a lot of work with uh, Edge AI, which is Wasm Edge and Llama Edge, right? So on the edge, you not only have large language model, but also has one of the important AI models that you have to use are the voice models. So to do voice recognition and also voice generation, right? So one of the things that people has always wanted to do is to have the end-to-end voice processing pipeline, which if you look at our project like EchoCat and things like that, they will do that. So meaning that you have an application that pick up voice from the user, and then use voice recognition to turn that into text, and then use large language model or some other processing to generate a response of that text, and then turn that response into voice again and send it back to the user through TTS, right? But the process in the middle is not just any large language model to process the text. You can do arbitrary complex stuff. For instance, you can hook up cloud code in there so that your text becomes a command or the one-shot prompt for cloud code, and it would take the text generated from your voice and do things, and and after it's done, it gives you the results, right? So there's lots of things that can be done in the middle, between the speech recognition to the text to speech. The processing that happens in between could be arbitrarily complex, or it could be completely user defined. This is a very good use case for sandbox, right? Because it's all user defined code. If someone release something interesting, that's I would run it on my own computer. I would run other people's code, right? So to have a sandbox around it is one of the very desirable features that I've just mentioned, right? With open cloud, Ironclaw, and the pervasive use of sandboxing in agents and things like that. So through this project, we want to experiment with the new Wasm WasmEdge Rust SDK that we have created to provide the sandbox the application logic in between the ASR, the voice to text model, and the TTS, the text to speech model. So again, this entire application is created by cloud. I actually didn't write a single line of code. So my role here is mostly just um, uh, experiment with it and build test cases. And when it's stuck, tell it, maybe you should explore this, maybe you should explore that, right? That's the whole role that I played. So it generated the entire Rust application, and what it does is it ported the inference logic for the two state-of-art voice-based AI models. One is Chairman 3's ASR to do voice recognition, and the other one is Chairman 3's TTS that do the voice synthesis. And Chairman 3 ASR and Chairman 3 TTS are both only available as Python packages. Okay, so if you look at their repository, they have different backends. They have like PyTorch, VRM, and SG9, and those backends. But the inference code, the transformer, and all that is entirely written in Python. So our first task is really to port those projects into Rust. Again, AI did all that. So it took the Python transformer libraries, the NumPy, and the PyTorch libraries and all that, turned that into Rust. And so we have separate projects for those, right? So they did. The Cloud Code did all that within a day, and then we are in a position to write the voice actions by creating a new Rust application using those new Rust modules that the AI has written, so that we have the ASR, the voice recognition and voice generation on both ends. And then in the middle, that's the Rust application. Like I said, load the WasmEdge Rust SDK so that it runs the Wasm module in the middle to do any kind of processing. So let me show you some of the, two examples of the Wasm um, um, application that we have. So, so those are what we call the plugin modules. So it's lib.rs. It's not the main.rs because it doesn't compile into self record. It only compile into a module that has a function, so that through the SDK, the host Rust application can call the function, right? So there's some boilerplate code that I don't think you need to care about. So you can leave when you write a plugin for this system, you can leave all those codes intact because those are just memory management. And the important thing is this. Sorry, you can leave all those intact. The important thing is this is a process. So there's a single function called process. It takes input as a string, which is the input that coming out from the voice recognition, and output another string, which is the result of the action that goes into the TTS. So in a simplistic form, it is just echo, right? It's put the input string to the output. So when you run the whole pipeline, what you would experience is that you would say something, and the computer would say it back to you, right? If you say "hello, computer," the computer would say "hello, computer." That's you know, um, because the processing logic that's written in Wasm is like that, right? So it just echoes whatever you says back to you. So, but then there's something more complex, because the Echo project, shows a point, but it's not really that interesting. So we have another application which has a more complex um, process module. In the process module, it uses the token runtime to make a network call. So it's Tokyo, right? This is one of the IO stack um, in Rust that is supported only in WasmEdge, right? It's to make this type of networking calls. So in the process, so it goes to call OpenAI, meaning that it takes the input from your speech recognition, from the speech recognition module, and send that as an input for OpenAI, and ask OpenAI to come back with the answer, right? So now you can ask questions like, what's the weather in Austin? What's the weather in New York City? Because OpenAI has built-in web search, so it would be able to find that information and return in natural language and then speak it, right? So it has the OpenAI API here, and it gets the API key from the environmental variables from the system, the OpenAI API key, and then goes on. So it's a fairly complex. It's not super complex, but it's about 80 lines of code. The whole thing. So the process function is defined in this way. But you can imagine you can do the processing function in any complex manner that you want. You can call multiple services and chain them together, or you can have your own processing logics. For instance, you can say some of the TTS has problems pronouncing numbers. So you could have a little application that turns all the numbers in your text into pronounceable numbers. For instance, instead of 20, you gonna spell it out in English 20, right? So there's lots of things that you can do to manipulate your input and output, and then to generate actions based on your input, and then collect the outcomes. Like I said, you can have the whole cloud code hooked up into the system like that. And so once you have the Wasm project, you compile it to WasmEdge binaries, and the way that you use this application is also very easy. But you compile this application is this, right? So basically you have input, which is an audio file, and here you can we have built um, you know um, other features that you can connect to your microphone, and you can connect to your browser, right? And then it would generate the output. And here is that the model files you're going to use, right? Because this is just a Rust application. It doesn't itself has AI models, so you have to download those AI models separately. Those are all open source models, and so you tell it which speech recognition model you're going to use and which TTS model you're going to use to generate speech, and then this is the important piece is the WASM, right? So you have input, you have output, you have the model to process input, you have model to process output, and then you have the Wasm module that has all the logic, how to process how to, from the input, how to get the output, right? So here it's just the echo, like we have just shown. You just do nothing, just copy the input into the output. But you can have multiple Wasm modules that chain together. Let me see if I have an example here. Um, I may not, but so you can have multiple WASM tags. So here is WASM echo, and you can add another one here, dash dash WASM space lim.wasm, right? So that's um, uh, that the system would know that it can call two WASM modules in a row, each in their own sandbox, right? So so it can do the echo first. Echo goes from input to output, the same text, and then use LM that goes to call OpenAI. And what it does is that it take input and then go call OpenAI and then come back with a result. Of course, you can do anything, you know, like I mentioned, you could use Llama Edge to run large language model locally. So Llama Edge has an SDK that you can, from your Wasm application, you can directly call that. You can download any of the open source large language model and try to run it locally through this pipeline, right? And everything, all the actions, all the user written code is properly sandboxed and it's all portable. So, I think this is one of the use cases that we really want to explore, want to push with the community to expand how WasmEdge is being used. WasmEdge role in AI, right? That's um, like I said, we also very welcome, AI contributions to the WasmEdge projects as we do ourselves very often. We a lot of the code that we write today is all based on AI. However, I just want to be cautious, because um, we like AI generated code, but not just untested random code with AI written, documentation and all that. That's not probably not what we are looking for, but we are looking for thoughtful and well-written code that's essentially human-guided AI to come up with all those, right? So that's the topic I want to talk about today. Yeah. So if there's any question, you can ask me, and if not, yeah, I think we are at 8 minutes left for the meeting. So let
I had a
me stop
question.
sharing it. Yes, please.
So I do a lot with, I've been following the WasmEdge community for a while, and I do a lot of building on the Akash network, decentralized, like basically writing SDLs, YAML files, and trying to deploy applications. So um, the requirement is that it's a Docker, there's a Docker build. So I guess my question is, I've seen there's been a lot of cool projects and even including this one that I'd like to try to deploy. All that really is needed to deploy on Akash is again the Docker image. So I'm wondering if anyone, if yourself, Michael, have you experimented or know about Akash and or have a recommendation for how to look to leverage the Akash decentralized cloud infrastructure to deploy Wasm applications?
Yeah. So Akash has a GPU compute in your network, right? You are one of the GPU sharing framework.
Correct.
Uh,
You can select. You can fish basically for GPU providers.
yeah. So I think Llama Edge works well on that network. I've heard people, because I've seen people that has done that, to containerize Llama Edge, because Llama Edge is a product that use a lot of GPUs, but also this voice action framework is also the same. It's calls those AI models, and the AI models can run on CPU, but it can also run on GPU, right? Or it runs much better on GPU, in fact. So if the container that you provide have CUDA exposed inside of the container, then that would be um, you know a, a very good use case for those type of applications. Yeah. So I've seen people do it. That's because when we because WasmEdge has a pretty big community, and people are looking for cheap, low cost GPU resources. And I've heard, those, Akash has coming up as one of the options. Yeah.
Thank you for that. Like for example, I deployed like Agent Zero. I was able to
Mhm.
deploy for like $1.74 a month to host on Akash. So I try to one of my objectives is to find interesting, useful projects and get them on Akash and
Yeah.
see if I can provide it to people. For example, and another example, I actually, it's funny, I tried to deploy Ironclaw on Akash, but I had a lot of trouble. Um, couldn't really figure out. I got stuck. I was using AI, but I got stuck on it would deploy, but I couldn't figure out what I was missing. I had to build a Docker image myself. So yeah,
This is very interesting. That's if you try OpenCloud, you'll probably also have a lot of problems because those systems are designed for micro VMs, not for Docker. It lacks some, like LaunchD, it lacks some operating system level utilities that are not commonly available in containers. So I thought that was
OpenClaw
very
has been
interesting.
OpenClaw has been done. The Akash community actually came together to make a. There's even a service that will deploy for you on Akash. So
Yeah,
um,
because
yeah,
otherwise it's more popular, right? So when
right.
OpenCloud, what I really meant is that when OpenCloud first come out, it also has problem deploying on Docker. It has a very convoluted way to
Oh,
deploy.
okay, okay,
So a lot of people work on. The Ironclaw obviously is not that popular, not as popular as OpenClaw. People
exactly,
haven't, yeah. So,
exactly.
but
Yeah,
also, like I said, so Ironclaw sort of solves the security problem with using Wasm as
that's right.
sandbox everywhere. So it
That's
has
right.
less need for Docker. But
Oh,
I do think it's a very
I see.
important addition to the community. If you can do Ironclaw, and yeah, we also love to see things like OS actions and things like that, which are essentially much simpler agent frameworks, right? Because those clouds are sophisticated agent frameworks that have multiple connections, multiple loops, and things like that. But you could also have very simple agents where it's just the processing input into our output. And so we love to
Exactly.
see those working on inside Docker and on Akash Cloud as well. So yeah, that's I see a lot of opportunities with that we could potentially collaborate.
Okay, that sounds good. I actually recently deployed there's a I don't know if it's a state of the art, but Strand, are you familiar with the Strand Rust coder model that was recently released?
Oh, yeah, I haven't used it, but I heard of it. Yeah.
So I was actually able to deploy that on Akash. I wasn't able to run it to generate code, but I was just really testing if I could get the SDL, if I could find the GPU, and and it worked. So I kind of stopped myself short from trying out curl commands to see how good it was. But yeah, that was also something that one at least was successful. And I used uh, ironically OpenClaw to get it running
Mhm.
on Akash.
Interesting. Yeah, that's
My goal is my goal is to actually put a front end on it and have it like user facing. So let's start with the command line probably. Sorry, go ahead.
yeah. I think those are excellent ideas. There are lots of things that we could potentially do, right? That's you know, so one of the things that we could do is that we could take our ASR and TTS model and put them on Akash because there's lots of because all of them provide the OpenAI compatible API endpoints, so they're pretty well set up for cloud deployment. Because once you deploy, they become API service that your other applications or your other cloud agents like OpenCloud can then make calls to them to consume their services, right? So yeah, that's but but yeah, that's I have to look into it again. That's I've looked into your network like a couple months ago, and yeah, that's it's I'm impressed, but that's but I haven't used it for a while, so we're taking a look. Thank you. Yeah. All right. Yeah. So I think we are close to the end of the meeting, and thank you very much. And I hope you. So please do get in touch. Our contact is in our GitHub repository. You can find my email address and all that. Or find me on Twitter. I'm easy to find. So with that, I think thank you, Hadai, for the excellent introduction of our internship program. And so I'll talk to you guys next month. Thank you.